Hi everyone, I'm Gabriele Masina and I'm presenting the paper on CNF Conversion for SAT and SMT Enumeration in collaboration with Giuseppe Spallita and Roberto Sebastiani from the University of Trento, recently published on the Journal of Artificial Intelligence Research. SAT enumeration is the task of enumerating all the truth assignments satisfying a Boolean formula phi. Consider, for instance, this formula here, then TTA of phi is this set of total truth assignments satisfying it. Since they can be exponentially many, a key for an efficient enumeration is that of finding short partial truth assignments, where each represents exponentially many total truth assignments. This task extends naturally to SMT, where we want to enumerate all the truth assignments satisfying a first-order formula phi and a theory T. Consider, for instance, this formula here and the theory of arithmetic. Then TTA of phi is the set of all total truth assignments satisfying both phi and t. Also in this case, we look for short partial truth assignments, each representing up to exponentially many total truth assignments. Why do we do enumeration? Our main goal is probabilistic inference, and in particular, weighted model integration, where we want to compute an integral of some probability density over a non-convex region represented by SMT constraints. This integral is not directly computable because we have to decompose phi into convex regions, and we can do that by enumerating a TA of phi, which is represented graphically here. We could also enumerate a set of total truth assignments satisfying phi, but this will result in many more integrals to compute. So the problem we highlight is that of CNF conversion. In fact, SAT solvers and SMT solvers work with CNF formulas, and we highlight how different CNF encodings can impact the effectiveness and efficiency of enumeration. A typical encoding use is that byte citing, where each subformula is substituted by a fresh Boolean atom, and the definition with a double implication is conjoined to the encoding. If we enumerate partial truth assignments over this encoding, we notice that we enumerate more partial assignments than expected. In particular, here we enumerated two partial assignments instead of a single one, assigning just A to true. And we have shown that in general, a partial assignment satisfying phi not necessarily satisfies its citing encoding. And the reason is that its definition with a double implication forces its partial assignments to assign a truth value to its subformula phi I, which cannot act as a don't care. So we propose an alternative encoding which combines a NNF encoding upfront and then uses the Pleisthen and Greenbaum encoding, which labels subformulas with a single implication if they occur with a single polarity. And if we then enumerate over this encoding, we notice that, as expected, we have a partial assignment assigning just A to true. We have proven this theorem that if a partial assignment satisfies phi, then this satisfies also its encoding with NNF combined with Pleisthen and Greenbaum. The reason is that, so Pleisthen and Greenbaum encoding assigns labels subformulas with a single implications, and definition can be ignored by assigning the corresponding atom to false. Why NNF? The reason is that if a subformula occurs with double polarity, instead of adding a double implication, NNF splits it into its positive and negative occurrence, which will be labeled with two different atoms with two different definitions, which can be both ignored by assigning the corresponding atoms to false. These are some experimental results. On the left, we compare the number of partial assignments, and on the right, the total time. On the Y, we have our encoding, and on the X, we have the cited encoding. We can see that with our encoding, we improve by orders of magnitude. So takeaways, the CNF encoding impacts enumeration performance drastically. The citing encoding is not suitable for enumeration because it forces finding many long partial assignments, whereas a combination with NNF plus Pleisthen and Greenbaum encoding is very good because it allows to find fewer shorter partial assignments. That was all, and if you're interested in the paper, please scan the QR code, and thanks for your attention.